Hi everyone, in this video we are going to talk about this idea of constants and proportionality. This idea of constant and proportionality is useful for many physical chemistry chapters. So this idea of constants and proportionality is definitely not foreign to you. You would have somehow seen them in the earlier chapter where we talked about the dilution formula C1V1 equals to C2V2. So how did we go about deriving this equation? Let's look at the equation for aqueous solutions. So number of moles is equals to concentration times volume. So what happens is that when number of moles remains constant, alright, I will use K to show a constant. C times V is equals to a constant, which means when my volume goes up, my concentration automatically goes down, right? So much so that it maintains my number of moles as a constant, right? So when we dilute something, the number of moles stays the same, but because of the volume changes, right, the concentration also changes accordingly. So if you think about that, all right, simply what we can say is that C1V1 will now be equals to C2V2. Right, so using this idea, we can apply that to our gaseous state, all right, our gas law PV is equal to nRT. All right, so in this example, right, we are given PV is equal to nRT, where there is constant T and constant N. So what I'm going to do is for the different units or variables that are constants, I'm going to give them a tick. So this is a constant, R is the ideal gas constant, so I'm going to give it a tick. T is also a constant, so PV is equals to a constant. Therefore, P1V1 is equals to P2V2. So this is the first way to present it. So when we talk about the changes in volumes, what happens to the pressure? When we talk about change in the pressure, what happens to the change in the volume? So these are the cases where we will be able to use such an equation. On the other hand, if we want to plot a graph, right, what we can do is to show that PV is equals to a constant, or P is equals to K over V. So this allows us to plot two different graphs. We can plot the graph of PV against P or V or any other things, and we realize that if it's a constant, it's a horizontal line of K. So since PV is equal to nRT, this line is also equals to nRT. Alternatively, we can also plot another graph where we plot P against V, and since P is proportional to 1 over V, it looks like a Y is equals to K over V graph. I can, however, plot P against 1 over V, right, and what this looks like is essentially a Y is equals to Kx kind of graph, where X is 1 over V, Y is pressure, and this is a graph that looks like that. Alright, it's a diagonal line with a positive gradient. So this idea of constants and proportionality helps us to understand how to plot graphs using the second form, how it allows us to do various calculations using the first form, and the last thing that it is useful for is to tell us the different types of ratios. So what this means is, for example, if I were to look at this idea of PV is equal to nRT again, but now I have constant constant volume and constant temperature. These three will be constant, so P is proportional to N. Right, so this simply means that the pressure ratio is the same as the mole ratio. What it means is that when the number of moles of gases multiplies by 2, my pressure will immediately double, given that volume and temperature is constant. Right? So with that, this is how we can use the idea of constants and proportionality to tackle different questions and learn some of the more advanced physical chemistry concepts.